In recent years, the Tour de France cycling race has been plagued with accusations that cyclists have been taking steroids to boost their performance. Testing for these steroids has been difficult. The level of steroids that naturally occur in the human body can vary between individuals, and the levels can change throughout the day. Testing for the presence of steroids is expensive and time-consuming. Racers are randomly chosen for drug tests. Suppose that 2% of racers have taken an illegal steroid. Assume that if they took the drug, there's a 99% chance that the test will return a positive reading and the athlete will be disqualified. These tests are not perfect. Even if the cyclist did not take a steroid, there's still a 3% chance that the test will return a positive reading and the athlete will be unjustly disqualified. So the first part is to draw a tree diagram showing the probabilities for the sequence of events in which an athlete either takes or does not take a drug, and then is tested for the presence of the drug. So always, as you know, the tree diagram starts from the starting point, which we can label as S. And first there are two ways to go. Okay? The first thing is to see if there's a probability for taking the drug and the probability of not taking the drug. Okay, so we're gonna represent D event that the drug is taken. Okay, so we'll have respectively the event that the drug is taken and the event that it's not taken. Right, we can denote it as D complement. So what is the probability that the drug is taken? So notice, going back to the text, it says suppose 2% of racers have taken the illegal steroid. Right? So the chance of taking the drug is 2%. And 2% expressed as a decimal is 2 divided by 100, which is 0.02. So the probability of taking the drug is 0.02. Now, of course, the complement is going to be 1 minus that, right? Because the total probability is always 1 and not greater, right? So 1 minus 0.02 is going to be 0.98. That's the probability of not taking the drug. Okay, the next thing is, given that you take the drug, what is the probability that you're going to be tested positive on the test? Okay, now how do we determine this probability? Well, we have to go back to the text. It says that if you took the drug, there's a 99% chance that you will return a positive result and will be disqualified, right? So 0.99 is a chance of scoring positive on the test, right? So we can label it as POS. And of course, 1 minus that will be the complement of the POS. Okay, so that's going to be 0.01. Now, suppose that you did not take the drug. Let's see what that gives us. What's the probability of scoring positive when you did not take the drug? Okay, it says that the test is not perfect. Even if the cyclist did not take a steroid, so we're going this way, there's still a 3% chance that the test will receive a positive reading. All right, return a positive reading. So 3% chance that you will still test positive on the test even if you didn't take the drug, right? So 3% expressed as a decimal is 3 divided by 100, so 0.03. And 1 minus that will be the complement, right? Scoring negatively if you did not take the illegal drug. Right, so 1 minus 0.03 is 0.97. Okay, so now that we got that done, we have all the numbers that we need. We can move to part B. What is the probability that a randomly chosen cyclist will be steroid-free and will still test positive for steroids, right? So it's two events happening at the same time. So the probability basically of testing positive and also, and also not taking the illegal steroid, right? Because steroid-free means you didn't take it. So basically what the question asks you is to find the probability of scoring positive together, right? That's why we're using intersection here and sign, together with the fact that you did not take the drug, the illegal drug, right? Because steroid-free means D complement, essentially. Right? So now, as you know, this requires a Bayes formula to be used and to split this up into a product, basically, of a conditional probability with individual probability. So basically what it means is that we have to find the probability that given that the tester did not take the illegal drug, what is the probability of scoring positively on the test times the probability, individual probability of not taking the drug, D complement. Okay, so this is a very important base formula. Be sure you understand that. So obviously you're going to keep the same order. The POS will be on the left here. D complement will be on the right. This is a conditional probability right here, given that you didn't take the illegal steroid. What's the probability of scoring positive? Times the individual probability of the conditional event. Individual probability that you did not take the drug. Okay, so now we can use the tree diagram for that, right? So we know that the conditional probability means that you first did not take the drug, right? That was 0.98. Now, if you did not take the drug, what is the probability of scoring positively, right? That was determined to be 0.03, this conditional probability. And then individual probability, the probability of not taking the drug, is just this first row here, the bottom row, which is 0.98. 0.98. Okay, so that should turn out to be 0.0294. Okay, so this is the probability that a randomly chosen cyclist will be steroid-free and will still test positive for steroids. Okay, both together at the same time. Now, the last part here, it says, what is the probability that a randomly chosen cyclist will be disqualified due to a positive reading? So that's the same thing as saying, what is the general probability that any randomly chosen cyclist will test positive, right? So basically, the probability of testing positive. Now, as you know, this can come both ways, okay? This can come, the probability of testing positive can come with taking the steroid, which is the D event, and not taking the steroid, which is this probability here, right? So we can have positive together with the drug being taken, plus another event. That's why we're adding it, because it's a separate event, mutually exclusive events, right? Scoring positively together with the fact that you did not take the drug. All right. So now, as you know, splitting this up into conditional conditional multiplied by the individual is done in the same manner here as we did it here, right? So basically, we're going to find the probability of positive given that the drug was taken times the probability of the drug being taken. That is stands for the first term that you see here with the intersection. This is how we split it up using the Bayes rule in the same way as we did here. And then here you don't have to do any work because we already solved that. This is part B, right? It's just 0.0294. All right, so let's find out what this is using the tree diagram that we created before. So given that we went to the D, right? So given that the drug was taken, that's 0.02. What is the probability of scoring positive? So if we go here, what is the probability that we're going to score positive? It's going to be this one, right? This branch, 0.99. 0.99 multiplied by the individual probability of taking the drug, which is this first upper branch, 0.02 from the starting point. 0.02 plus 0.0294. So what that should give us is 0.0198 plus 0.0294. And if you do this right, your calculator should give you 0.0492. So the general probability of scoring positively for any randomly chosen cyclist is going to be 0.0492. All right, and that's taken into account all the possibilities according to the tree diagram. Thank you so much for watching, and I'll see you in the next video.